Okay. So there's our question. Our answer to our question. Just replay. All right, and then our vocabulary. All right, so consistent having at least one solution. They intersect just at least once, if not more times. Inconsistent has no solutions. What kind of line system would be inconsistent? Parallel lines, yep. Independent has exactly one solution. That's what we've been looking up above, those intersecting lines. And then dependent has infinite number of solutions. Yeah. Exactly. So let's look at some characteristics here. So just to point out, is independent consistent? Are independent graphs consistent? Yes. Are consistent independent? What would you say? Sometimes, always, or never? Sometimes. All right. So are dependent consistent?
Yes.
Always.
Always.
Always. But are consistent dependent?
No.
That would go back to the sometimes, right? So just note that independent dependent can be consistent, but consistent doesn't necessarily mean one or the other of these, right? Inconsistent kind of reigns on its own, no solutions, right? Okay. So for the characteristics here, we'll start with a consistent and independent. Just our normal intersecting lines, just wherever they intersect. We're going to get exactly one solution. Our next one we're going to look at is our consistent dependent, which Dylan pointed out would be the what? Same line. So I draw one line and then I draw the second line right on top of it. They would be the same line. And those would have infinite many solutions. Second period had a little bit of trouble determining between infinite solutions and all real numbers. If I ask you on a consistent dependent what the domain is, we're talking about one set of values, right? The x values. Then you could say all real numbers, right? If I ask you about the range on this consistent dependent, it would be all real numbers, right? But when I ask you about this set of points, how many points do they intersect at? They intersect at every single point on that line. And how many points are on that line? An infinite number. We're no longer talking about a specific value. Does that make sense? Okay. And then lastly, the inconsistent, which Arlie Beth told us was going to be what? Parallel. And they will have no solutions because they never intersect. My hand's not steady here. It's hard to write with your hand just hanging over the edge, you know? I don't have good control of it that way. Any questions about the characteristics in those vocabulary terms? All right. Moving on to our steps to substitution. Just a second to get all that. Oh, thank you. Somebody sewed it on. Where is your eye? Someone else wanted it like a child. Yeah. I watched Walgreens have a good night. Hard to beat a good man twice in a row, though. Just saying. I have a feeling it was because everybody threw them off their mojo by wearing their jerseys yesterday and shirts. We won't do that again. Okay, we good? Blood will go back to her normal, superstitious baseball mom and self. All right, substitution. To refresh us on the steps here, we're going to jot them down. Step number 1, we're going to solve one of the equations for one variable. Don't think of this as putting it in y equals mx plus b, because you can solve for x or y. Doesn't matter here. You're just getting one variable by itself. You okay? All right, step 2. You're gonna, here's where the substitute comes in. You're gonna substitute the resulting expression, the one from step 1, into the other equation. And solve for the remaining variable. So you're going to take whatever one you solve for, plug its expression in, and step 3, You're going to substitute the solution from step 2. So we're going to substitute twice. Into one of the original equations. And solve for your second variable. Why do I need to solve for 2 variables here? Trying to find a point of intersection. I need my x and my y. Another thing I want to point out too, why we place it or substitute back into the original equations is because if we've made some mathematical error in the one that we did some changes to here in step 1, then we're plugging it back in the wrong thing back into the wrong thing. We're causing a mad cycle here. So if we go into that original one, if something was wrong, maybe it'll ring a bell to us. Hey, this doesn't look right. Something's not right. Let me go back and check my math. Okay? So always go back into that original equation. And then lastly, we got an x and a y, so we're going to write our answer as a point. I'll be honest with you. I like to substitute best. I know a lot of people that'll jump to elimination first. It just depends really on what the problem looks like as far as what you should or should not do. There's no wrong way, but there's some easier ways. So when I look at this, when we know we're substituting, which one looks easiest to get ready to substitute with? The second one, I'm going to get the y by itself. If the x was by itself, I would get the x by itself, right? I'm not working to get this in y equals mx plus b. I'm just working to get a variable by itself. And my new equation would be y equals 7 minus 2x, or negative 2x plus 7. Again, I'm not trying to get it into slope-intercept form, so that part doesn't matter. This is step number 1. Step number 2 goes on to say that you're going to substitute this expression, this one right here that represents y, into the other, not the same one. Plug it into the same line, it's going to tell me they're the same line, right? So I got to plug it into the other one to get a resulting x variable. So I've got 5x minus 3, but instead of y, I'm going to use 7 minus 2x equal to 23. And this is part of step 2 here. So I'm going to solve for x. First step will be to distribute. So I've got 5x minus 21 plus 6x equal to 23. Next step is to combine like terms. So 5x and 6x make 11x. And now I have a 2-step equation. I'm going to add 21 to both sides. And divide by 11. And x is equal to 4. Now what?
You plug the 4 in the equation.
I'm gonna plug it back into one of these original, doesn't matter which one. So step 3, we're plugging it back in. So I have 2 times 4 plus y equals 7. I'm all about those smaller numbers. I'll be real honest with you. I'm picking the one that's gonna take less work. All right, 2 times 4 is 8 plus y equal to 7. And I just need to subtract 8 from both sides. And y equals -1. Yeah, oh no, you're just, oh, sorry. Your arm went up and I thought there was a question, then I realized it wasn't. All right, step 4. Put into the point, x comma y, 4 comma -1. And that's my solution. That's the point of intersection.
Are you teaching it as a new thing or do you
This is a review.
Oh.
Okay? So practice 2. All right, there's the problem for you to try.